Okay. Pythagorean theorem review.
A squared plus B squared equals MC squared.
I'm confused.
Almost. No, it's review.
Oh yeah, I was off by an M.
Pythagorean theorem.
MC squared.
Okay, so here's what I'll say. When I say review in here, all I am saying is that the state of Oklahoma, when I'm like planning my lessons for you guys, okay? State of Oklahoma doesn't really give us like a step-by-step, here's what you need to do, but they say, here's what they should have learned in previous classes, here's what you need to teach them, okay? When I say review on something, that is just because the state of Oklahoma has told me this is something that you learned in a previous math class. Whether that is the case or not is out of everyone's control in here, correct? Okay, so we can go over it. That's no problem, okay? The Pythagorean theorem is used whenever you have right triangles, okay? I'm just talking at this point, but you do need to write down this top part right here with the two triangles, okay? I have the triangles tilted this way on purpose, and that is because you more often will not see them situated this way. You more often would see them situated how?
Not right triangle?
Yeah.
What is that? Isosceles?
It's still a right triangle. It's just tilted.
It's right, but if you turn your head.
Oh, and usually you have them like
So you have a couple different pieces of a right triangle. Okay, you have legs, and you have the long side, which is always opposite the right angle. Okay, so if the right angle is right here, then the opposite side is this one at the bottom right here. That is called the...
Is that hypotenuse?
There we go.
I said hypotenuse.
You said hypothesis.
Jesus, so aggressive. I heard you.
Always aggressive.
I heard you. But no one else heard you, so I was going to let other people answer too.
No, I didn't hear him. I heard it.
Definitely.
It's the apple, not you, Gage. Okay.
It's a warning shot.
Wouldn't it be at least? It's at least 40.
Hypotenuse.
Do I
The
need to
longest
write
side with right triangle.
is that a U? Wait, I don't know.
Hey Siri, how do you spell hypotenuse?
I don't think that's how you spell it.
Hypotenuse. HYPOTENUSE.
That is not like an N. That looks like an
Okay.
upside down B.
It looks like a U and an N and two greens.
I'm very excited to trash y'all's handwriting. So, okay, hypotenuse. Okay,
Hey, you can't trash mine. I didn't say anything.
okay. Stay with me, guys. Stay with me, please. And by stay with me, I mean let's get with me because we just started. Okay, so we have when we're using the Pythagorean theorem. Okay, it is helpful in determining the length of your sides of a triangle. Okay, so we've got two sides given, and then we have one side unknown. Okay, the side unknown is the hypotenuse. Okay, in the Pythagorean theorem formula, which is a squared plus b squared equals c squared. Okay, you have your a side, you have your b side. Which one you make a and which one you make b does not matter. Okay, what does matter is that the hypotenuse is always c. Okay, it has to be c, has to be hypotenuse. Okay. So when I'm filling in the Pythagorean theorem and then I'm placing in my values, okay, you're going to plug them in just like you should in any algebra. Instead of the variable, I've got parentheses. And then we've got right here, okay? So I've got a squared plus b squared equals c squared. The squared part is always the part that students forget, okay? You've got to have your exponents in there. So a is 4.
4.
B is 5. Do we know what c is? We don't, so we'll just call C X. Okay. I did mention the last time that I saw you guys that we will do a square root and a cube root lesson, okay, that I'll squeeze in. I need to do this stuff right now because we're going to be taking a benchmark in a couple weeks. So I will get the square root and the cube root lesson in. If you're confused about taking square roots when we get there in a second, that's okay. Okay, we'll figure it out together. What is 4 squared? 16. What is 5 squared? What is x squared?
42.
Okay.
Are you okay?
What is 16 plus 25?
42.
41.
Good.
Yeah, I'm trying to get the.
Oh, Jesus did this
C
last
squared
year.
part.
Where he
He's
answered
known.
one.
I've heard.
Oh, yeah.
Yeah, he knows the.
I honestly feel like Jesus doesn't feel well if he answers the question correctly. So.
Yeah.
All right.
I did that one too.
So we've got 41 equals x squared. We need to get x by itself. What is the inverse operation?
Multiplication.
Is it
The subtraction.
So proud.
what?
Yes, square root. Okay, so we have x squared. We need to undo that operation to get x by itself. To undo a square, we have to square root it. So you're going to square root both sides. Okay,
That's a lot of squares. I'm not sure I can handle
especially while we're working with a triangle. It's crazy.
There's so many sides.
Okay,
Too many
so
that. It's too much.
No,
geometry.
man.
here is how I want you to write your answer. Now, this is a teacher chooses sort of thing. My preference, okay? My preference is that you answer it like an algebra student, which is, okay, the radical and the exponent will cancel each other out. You're just left with x. And then I can't reduce that down because 41 is what kind of a number? A prime number.
Oh my gosh.
So I'm just going to leave it as x equals the square root of 41. Okay. Now, when you punch that into your calculator, the square root of 41 will be somewhere in between 6 and 7. Mm-hmm.
Really?
Mine, every time I get a calculator, it can't do
What's it at, Gage? Between 6 and 7? Okay.
Wait, so
Sorry, I didn't mean to call you out.
okay, my calculator is doing the thing where it doesn't do the square. It always says square root of 41.
So you gotta go from math print to classic in the mode section, okay? If you want the decimal. If you just want the radical, keep it in math print. So between 6 and 7, okay? That's really not important. Okay, so let's look at the next one, okay? We're still working with a squared plus b squared equals c squared, okay? Let's say we have a, b, and c. So what's different about this one from the last one?
You know C, but you don't know
There's
B.
only one number.
Yeah. We have 2 variables, and we have our hypotenuse, right? We have our c. So a is going to be x plus 2 squared. I think I messed up. We'll see how this problem works out. Plus x squared equals 10 squared.
Wait, what?
Wait, isn't
Hey, X is
10
always C.
supposed to be B and X? No.
Okay, so
we have to
yeah,
reverse
so
the-
this one
C
is
always
different because you're given the hypotenuse, which is 10. Okay, you don't know B, you don't really know A. Okay, we just know the ratio. So, and I just pulled this problem from my brain, and actually now that I'm looking at it, it's going to be a confusing one. So, but let's keep working it. So,
Like I missed out on a lot.
I need to change this.
Yeah.
I need to change it. Hold on.
You suck.
That's
It
a
just
bad.
All right.
is
So instead of the beautiful triangle, now we have a like weird piece of pizza. Okay. Yeah. Do what? No, I don't. Sorry.
You have 1 second.
Imagine taking another.
Are y'all doing your notes in pen?
Yeah, okay. I lost my pencil again.
Well, there's
Ask
longer
somebody
there.
for a pencil.
Always pencils. Okay. That was my fault. I was about to get into some crazy quadratic algebra, and I didn't want.
Let's
Not today.
Can you give them 2 on both sides so you can have an X and X?
Yeah, but we were going to end up having an x squared, and we were going to have an x squared in more than one place, and it was going to end up being a nasty answer. So, well, I mean, no, I'm not going to do that now. I'll show you what it would have looked like after I finish the problem. Okay, so
2 squared.
we've got 2 squared plus
X squared.
x squared. Oh dear. Equals 10.
Squared.
Thank you, Bram. Okay,
I'm so smart.
I'm so proud. All right, so now, okay, we're working it the same way. Okay, we've got 2 squared. This is going to be 4 plus x squared equals 10 squared, which is 100. Okay, so we got to get x by itself.
Wait, let me write the
X
equation.
is 4.
Minus 4 from both sides.
Okay, you got to get x by itself. So we're going to move the 4 by doing the inverse. What's the opposite of a positive 4? Negative 4. Okay, last I checked. Then we will cancel out those 4s on the left. Bring down x squared. We have 100 minus 4. 96.
Oh man.
I always thought that division was an inverse operation.
What's that?
I always thought division was in it. So I thought X would equal 45 and 48.
Oh, I see what you're saying. So if it would have been, if it would have been 2x instead of x squared, yes. Because 2x is multiplying, so the inverse is division. But for an exponent, it's the inverse is taking that square root. Okay, so this is very important for those of you that do not feel comfortable finding the square roots. Okay, the last one was easy because we could not simplify 41. We can simplify 96. So we're going to take the square root of both sides. What that's going to look like is prime factorization. Oh my goodness.
Don't you love it, Aiden? I thought you loved it. That's what I thought.
That's good. Man, the more I zoom in, the more my pen messes up. All right,
I really want to say a word.
stay with me, geometry, please. I've got all this candy that would love to end up with you guys, but if I keep having to fight for your attention, it's not going to happen. Okay, what are prime numbers that I can divide 96 by? Hold on real quick. Have I done a prime factorization with y'all? Okay. So let's just try 2. Let's try 2. Does 3 work?
Yeah.
No, it
Wait,
doesn't.
listen, it
For
does.
division.
That's what we're doing. We're
My
dividing.
honestly,
Wait, no, wait,
very
no, wait,
confused because I was
We can divide by 32. Yes.
We can do 3.
Thank you, 32.
Okay, what's a prime number we can divide 32 by? 2. What's a prime number we can divide 16 by? 8. 4.
2. Yeah, 4.
Okay.
That's a lot of
That is a lot of 2s.
my brain.
Okay.
I
So, if you can remember, what is our next step when it comes to factoring?
You have to pair out the numbers that are together,
Yeah.
and you can only pair the 2 of them.
Yeah, so we're trying to group up a couple of like numbers, right? So we've got a pair of 2s and a pair of 2s. those pairs, okay, if we remember, okay, I always use, for square roots it's easier, but I always use a Valentine's Day example. Okay, pairs get to go out. Okay, so this 2 becomes 1 2. It's going to be outside the radical. This 2 becomes 1 2. Okay, like 2 people become 1. Okay. Okay. So that goes outside. That's the same with anything, Jude. Okay. So they go outside. We'll multiply them together. When I say outside, I'm talking about outside the radical. Now, what does not have a pair? The 3 and the 2. So both of them have to stay home on Valentine's Day. Okay? Which means they go back. They go back inside the radical. 3 times 2, which is what?
5.
6. So x would equal 4 square roots of 6.
That's a lot of squares.
Well, that's true. They can have a singles awareness day party.
That sounds like
Oh, it's like a rom-com. Okay. All right. So that is a brief overview of Pythag theorem. Okay. We will use it as we go through the year. We will hit another review when we get into triangles. Okay, but we're not in triangles yet. So,
the one that you said that you would show us, like before you fixed it.
oh well, I can do that real quick. Okay. So the reason that I changed the other problem, don't erase this. The reason that I changed the other one is because it would have ended up looking like this.
I really want to see this.
I did too.
Okay, so no, don't write this down. Don't write this down.
What if we want to?
What if we just we in the matrix?
It looks like you didn't put the other stick of the egg. Thank you. It looks like an
It's because my pen always runs out of ink.
Your pen can run out of ink.
No, it's digital. No.
All right, so just did y'all? How much did we get into quadratics last year? Parabolas.
Sure. Sure.
All right.
Show us an example.
Like on a graph, it would look like.
A good amount.
No. That's like
Okay. All right. So this is what we talked about. All right. How do they make us feel?
Change the idea.
I'm confused. Depressed. Not cool, man. Yes.
What the heck? Where did you get all these numbers?
I get it.
What happened?
Numbers be like,
What?
Aaron, I need help.
I need mental help, Mr. Sir. I rated it. Where did you get a 9? Oh.
Graham, here's a ring I picked up off the ground.
What's 96 divided by 2?
96 divided by 2? What's that?
32. 48.
48.
Oh, by 2.
Yeah, 48.
All right. So I guess y'all aren't going to call this a treat. If I can't factor this, then y'all are going to get to see the quadratic formula. So, all right. So here, this is a fun. No, I can solve this one. So, what is a factor?
What's a factor?
Y'all look at it any longer, you're gonna have to give it to me.
Multiple.
Okay. Listen, please.
Hey, stop.
What is a factor? What is the factor of 48? Where if you added those two numbers together somehow, it would equal 2. So your factors of 48, okay, are 1, 2, Can you divide 48 by 3?
No.
What about 4?
Yes.
Yes.
Okay. 5,
No.
No.
6,
No.
Yes.
8,
Yes.
9,
No.
10,
No.
12,
Yes.
24,
Yes.
48. Okay, so those are all the factors, okay, of 48. What two numbers could I put together somehow to get a 2?
48 divided.
Oh no, adding or dividing subtracting. I don't know what we're doing.
I
have
don't
no
like
idea what we're
that.
doing. Eight.
Okay, so that is technically the final answer to the equation, which is why I didn't do it, because it doesn't make sense.
It doesn't at all.
So it makes sense if we're doing, this is not to confuse anybody. You don't need to write this down. I already told y'all not to write this down.
Yeah.
This is the problem that I did originally by mistake. Okay, this is an algebra 2 quadratic problem. Quadratics are, instead of a linear line, okay, a straight line that only crosses the x and the y axis one time apiece. Okay, a parabola crosses the x-axis how many times? 2, because the x-axis is right here. The parabola comes down, crosses the x once, comes up and crosses the x again. This is why it has two. This is why it has two x's. Okay, so anyway, yeah.
So isn't that also used in like pre-calc or calc?
All the time.
Also, why do we need 2 algebras? Like, can't we just like get?
It's because they just keep building. So you get the base, and then they add it. And then, well, unfortunately, they don't ask our opinion. So.
When I go to high school, I'm gonna have to do algebra 1 again. I'm still
All right. Yeah. Okay. You just have to remind me. Okay. All right. Let's get into the actual geometry for today.
Wait, that was
The guys, the energy in here is too much. We will move to a seating chart if I can't get it controlled. I will not control you. You will control yourselves, or the seating chart will fix it. Okay? I am not a elementary school or middle school teacher. I am a high school teacher. So quit acting like middle schoolers is what I would say. Okay? If you like sitting where you are choosing to sit, fix it. What? Yes, go for it. Okay. Yes, the Pythagorean theorem stuff, okay, was just, well, it's supposed to be review, okay? But it was, if it was new, that's fine. We just needed to touch on it because we will have to do a little bit of it. Nice. We will have to do a little bit of it later on, okay? So I just want to make sure that we had it. So we are getting into finding area and perimeter on a coordinate plane, okay? So we're going to start with a couple of points. You can continue from. All right, guys. If we open up our Chromebooks again, it's going to be hard. Okay, I don't want to fight for your attention. My suggestion is to take a piece or two, right there. Okay, pass them around.
Oh, I have like, wait, is that graduation? Yeah. Oh, I have like.
What is your IQ?
What's up?
Look at how prepared I am.
Oh my gosh, it's amazing. Amazing.
Didn't you put like 3 packs of scrap paper on the list or something?
Yeah, and barely anybody brought any, so.
I brought
No, I didn't bring
they're all in my locker.
I brought some, but I kept it in my. I don't need that.
Hey, Mr. Bennett, I had a question about this definition I wrote down.
Okay.
It's from 2010. It's about a directed line segment. The point is, it's a mathematical term represented by an arrow with both direction and magnitude.
So it'd be like used in physics. What was your question?
If it was good or not.
Yeah. Now, my definition might be slightly different on the quiz, but I think with that one you'll be fine.
Yeah, it was by vector from Minions.
Y vector?
Because a vector is a line in both directions.
Very nice.
Don't worry about it.
There we go. Okay.
There's a dot in the middle. Euro. Oh, it's not.
Yeah, so guys, the way that this should look on your graph paper is not to make a box, but it's really just to one or two, okay? And you can always get more if you need it. The way to really go about this is draw your y-axis and your x-axis. Make sure you have them labeled, okay? And then you can go from there, okay? Putting a box around it is just going to it'll mess you up if you need to go outside of it, okay? So this first problem right here, we can just label problem A. Okay, and what we're going to do is we've got points at, we're going to go 2, 4. 4, 0. We'll go 0, -3. And we will go -3, 1. Y'all don't hate me. I drew one of these wrong.
Oh my god. Actually, I didn't write it down yet because I'm doing stuff.
The first one should have been 1, 4. So just move it over one spot.
Oh my gosh, I actually drew exactly enough spaces.
Come on.
What is it? 1, 4?
Oh my gosh, it's lines.
It didn't go where I wanted it to go.
It's
Okay.
like a parallelogram. Yeah, kind of. It's more like a rhombus.
I like roses.
Basic geometry I can understand.
Okay. A couple of questions. I'm going to zoom out a little bit, okay, just so you can see. So, we're going to just assume that the graph paper you're working off of is a centimeter graph paper, okay? I believe this is engineering paper, so it probably is a centimeter. But we'll just assume that it's a centimeter, okay? Centimeter. So we've got point A, okay, point B, point C, and point D. Okay, how would you find the perimeter?
I would count the number of units in the point.
So that's not a bad idea, except for
Your time.
we're cutting through a bunch of them in different spots, right?
The triangle where it's like
No.
half of base times height. Base times height
You
divided
gotta
by
do like the thing where you. Oh my gosh.
Whoa.
So maybe y'all are about to get rulers because we're passing out agendas on Monday, so it'll have one with it. But
I would draw a line in the
there's a
middle.
couple different ways to do this. Okay, I do not waste time teaching you the ruler postulate because the whole lesson is literally just measuring. Okay, how long is this line using a ruler? They're on their way.
Oh.
Okay.
That's my rules.
So, what's up?
I think I did it right.
So, and that's, it won't be perfect. but it's all right. As long as the points are accurate, then your measurements will be fine. So I heard a couple different ideas. Okay, one of them is distance formula.
Yeah.
Can you use the distance formula to help you find the perimeter? Yeah, you can. What is another way to do it? Measure it. Okay.
Do midpoint and
Or
multiply.
ask your teacher.
So if I say this is problem A, so I'll say question 1 for problem A. Okay. Find the perimeter.
Do we write this on the graph paper?
Yes. Yeah, you can do your notes on the graph paper. That's just fine. We're just going to assume that it is, but if you use the ruler, then you can just do whatever the ruler says. Okay. But yeah, no, that's fine.
Yeah, I
Yep.
believe there's a percent.
Are you?
Yes.
Do you have a pencil sharpener?
Yes. Over there or back there on the bookshelf. It's kind of in the corner, Bram. Okay, so your first task, find the perimeter. Your second task, I would like for you to tell me if I say adjacent sides, what am I talking about? Yeah, across from each other. Okay. Now, adjacent, okay, is not across from each other. Sorry, my brain broke.
It's opposite.
Okay. Yeah, next to. Okay, next to. So like if I'm standing right here and Jesus is right here, we're adjacent to each other. Okay. Adjacent is next to, but not in the same direction. Okay. So yeah. So like if we say AD, okay, which is this line right here, and CD, okay, I would like for you to tell me if the adjacent sides are perpendicular to each other or not. Okay.
No, I feel like I'm not.
Adjacent.
Wait, no. Well, I gotta figure out if it's a right angle.
Adjacent sides perpendicular. Okay, last one. I'll save the last one and we'll do it together. Okay, so if you haven't started working on these right now, you should. Okay, now let's talk about process. On number 1, you have 2 options. You can use the ruler, okay, or you can use distance formula. So I would use your notes from the distance and midpoint formula session that we did. Okay. For number 2, how do we know if 2 lines are perpendicular to each other?
They intersect.
They have to intersect, and they have to intersect very specifically. They have to share it. They have to intersect at a 90-degree angle, right? So they are perfectly intersecting. Now, how do we determine without a protractor if it is a 90-degree angle?
If it's 90 degrees. By putting a box.
By taking
These are great ideas. I'm just letting more people speculate.
Oh, yes, but like.
A protractor.
Without a protractor.
Because.
Your mind, man.
Yes, use your mind, man.
Use the right
That
angle.
sounds very,
Let's see if it.
Very Cheech and Chong-y. Okay.
I think it is a right
All right.
angle. I
So-
think they are perpendicular.
I put yes already, so
I'll give you a hint, but I'm not going to tell you. Okay. For adjacent sides, if they are perpendicular, it has to do with the slope of those lines. Okay. Do we remember how to do slope?
No.
It's X.
I bet we do. I bet we can figure it
Y
out.
equals mx plus b. Although I forgot how to do it.
That's just well.
Same
sorry.
thing, man.
Okay.
Same thing.
So if we have to do this one more time.
Unless you know it's square. You have the same shape in the
So that's it. That way, so.
I think it is a right angle because my ruler has a right angle on the corner and it's like
Oh,
perfect.
so we only have to do one of them. I was right. That's smart. That's smart. No, but it's
I didn't
not.
say it's not, but you need to be. So the thing about geometry is it's not about just having the right answer, but you also have to prove it with information. So you can't just know that it is. You have to tell me why you know that it's correct. I don't see as many people working on this as I would like.
Measure my millimeters. They're gonna be different for all of us though.
Yeah,
You could have wrote our
parentheses, x2 minus x1.
Well, yeah, I'm not worried about us being consistent as long as we know what we're doing. We'll talk about it.
I think
So if this one.
actually I think these I'm pretty sure these are perpendicular.
Pretty sure won't get the job done, Brian.
You better.
You gotta prove it. With math, you have to prove it.
But physically I can prove it though. Also there's human error in this, so it's gonna be hard to do it. But I did it anyway.
And then I think we add, we subtract them. We square those numbers, and then we add them together. Pretty sure. And then do we find the square root of that number?
We can just add up.
So 0 minus 0 minus 4,
We like protein agencies on the end. And then like why do you think this is more difficult?
1 minus 4 is
Yeah, it's gonna be sad.
And it's all your fault.
now 4 minus 1. 1 minus. I'm doing it different.
27. Oh wait.
That's a 30-second I got right now.
I'm doing 8 by 8.
Centimeters. 2 millimeters. 6 centimeters. 4 millimeters.
So where is it?
12 centimeters and 8 millimeters. That's what I got. It's gonna be different. Stop taking your money.
So, Graham, how is your day?
It
It was a day.
Okay, I found part of it.
Very
Wait, so then when I add the number, like, since I have almost different times, but I just do 5 that number times. I mean, I didn't do 5. I mean, that number.
Whatever number times 4, yeah.
That's actually really easy. It might be a lot harder.
That's a lot of geometry, actually.
in the
I only have 1 minute.
Not bad.
Mr. Bennett, do we have to use centimeters?
It was just, it's because that graph paper is in centimeters, so that's why.
Is it?
Like, yeah, I'm pretty sure.
I'm pretty sure it's
I mean, because I have it in inches.
Yeah, that's like.
I found it. It's 5.
Wait, so what do I do to find if AJ decides to perpendicular?
Come on, Brandon.
Okay. So
That's like 6.6.
if you used distance formula, okay, you should hit the nail on the head with the answer. If you used your ruler, answers are going to kind of be all over the place. Why are they going to be all over the place?
Because we all drew
Human
it
error.
differently.
Because first of all, we all drew it by hand, okay? Like mine up here is going to be all wonky with the ruler postulate because this picture is not scaled correctly because I had to copy and paste it on here and then I had to stretch it out a little bit to make it a little bigger, but I didn't stretch it out to scale, okay? So my distance between like my x's is different than my distance between my y's. So the ruler postulate is great to use, and if they ask you to use it on a test, it will be one where it's easy to measure. That's what I'll say. Okay? The distance formula will get you the answer every time. Yep. Absolutely. Great question. Yeah. So, if we used the distance formula, what was the measurement of one side?
3.
5. Okay? 5. Now, once you answer number 2, okay, you will know that this is a square. And so you don't have to do the distance formula 4 times. You can just do 5 times 4 to where the perimeter would then be 20 centimeters. We'll say centimeters.
Brandon got me wrong.
What would that be in inches?
It'd be like, I don't know, like 3 or 4. Hey Siri, how many inches is 20 centimeters?
20 centimeters
Is your mom? Yeah, 7.8.
Since when you multiply when you're trying to do the perimeter?
What's that?
Links is saying you multiply with
Well, yeah, but it's a square.
So it's just because this.
So here's the thing, but it's a 2D plane, and you're only doing the edges.
Listen, you take all the measurements that you put together, multiply by 2, and that's it.
So I only said multiply by 4 because if I get one side, all the sides are the same. So it'd be the same as if me doing 5 plus 5 plus 5 plus 5. They are. They're supposed to be. Yes.
Oh, so
Yep.
this is supposed to be a square?
Yes. Okay. Now, what I will tell you.
Yeah, that's because
Come back to me, please. Come back to me. You know, it would actually be helpful if y'all would quit checking out when I'm having conversations with other students because I might be answering questions that you will have in the future. Just for the record. Okay, so this is supposed to be a square. Okay. Now, in geometry, you cannot do this work by eyeballing the shape and thinking you know what the shape is. Okay. If you eyeball this, do you think it looks like a square? No. Okay. But what you think it looks like does not matter because we have real concrete locations for each of these points that are telling you exactly how long these sides are. Okay. Now, the reason that I hate the ruler postulate is for exactly this reason. Okay. And it's why I don't waste a whole day teaching it to you when I could just say, just use the ruler. Okay. So the distance formula will give you 20 centimeters. Okay. Because each side is the same length. Now, because each side is the same length, it's very easy on number 2 to say, yes, they are perpendicular. But in geometry, you've got to prove it. Okay. Postulates and proofs are very important. Okay. How can you prove it with math? Okay, I said one little thing earlier. Do you remember what it was? Slope. Okay, so we've got y2 minus y1 over x2 minus x1. Okay, when we are talking perpendicular, okay, the slopes. So when I say perpendicular slopes, I'm talking about the slope of this line versus the slope of this line. Okay? These slopes are opposite reciprocals. Yes, I think this is an important thing. Okay, opposite reciprocals. What opposite reciprocal means is that, let's just say, for instance, let me see if I can. Well, let's just pump these out real quick. So let's use the A to D and C to D. Okay, so we've got an XY on A and D. Okay, so I'm going to make D my X2 and Y2. I'm going to make A my X1 and Y1. Okay, so Y2 is 0 minus 4, which is my Y1. And then my X is going to be 2 minus 1, which is going to come out to be negative 4 over 3. Okay, so my slope for AD, my slope is negative 4 over 3. Okay, again, I'm using the y squared or y2 minus y1 over x2 minus x1 formula. Okay. Now, without doing the math, I can tell you what the slope of CD will be because of the opposite reciprocal proof. Okay, and that it is going to be a positive. Okay, so opposite. Okay, so the opposite of a negative 4 over 3 is positive 4 over 3. And then the reciprocal is you're flipping it. Okay, so the slope of CD is going to be 3 over 4. Okay, how do you check that? Yeah, just use the slope formula. Okay, and you could plug in your coordinates for C and your coordinates for D to check to make sure that that slope is 3 over 4. I would like for you to do that real quick. Okay, so use the slope formula. Which part? That one right there. Okay. Okay. What do we think? Yep. Came out to 3/4. Okay. If it didn't, okay, then I would just double check our math, okay, on how we combined the positive and the negative numbers. Don't forget, if you had a negative 3 on top and a negative 4 on bottom, that is a overall positive number, okay, because you got 2 negatives right there. And every fraction is a division problem. At least that's how you can look at it. Okay, so let's move on. Have I just thoroughly confused everyone? Okay, good. Let's keep going then. So that one just looks disgusting. So see if I can make it look a little better. All right, so I would prefer for you to use your same quadrilateral that you were just using. I'm just going to redraw mine so that it's a little cleaner. Man, this is the most judgmental class. I can only do the best that I can do. Okay. So we've got our points. Thanks, Bram. So this your same square that you were just on. Okay. So now we're going to get into partitioning.
I like that.
Yeah, partitioning is great. So partitioning is about breaking up a polygon, okay, or a just a larger shape into a bunch of smaller shapes. Okay, so we are going to partition this, and we're going to create a little square in the very middle of our square. Okay, and then we're going to make up the rest with with other 4 other shapes. Those other shapes are going to be triangles.
What we're doing,
Are we redrawing or no?
So you should do it on the same one. If you want to redraw, you're welcome to. Okay, I'm not going to control the way you do your notes. So the way that you're going to draw these triangles, okay, is just about connecting the points, okay, the vertices of this square. So from that top, okay, I'm drawing a line straight down and then across to the point on the left. Okay, if we're going from the one at the very bottom, so point C, okay, I'm going to come all the way up. I should use a different color. Coming all the way up this line to that same line that we were just on. Then we're going to do the same thing with C to the point to the right. And then we'll do the same thing from A to D. And this is why I said my scale is off, because what you should make in the very center, right here, is a square. Okay. Now, obviously, mine is a rectangle. But yours, if you're using your grid lines, okay, should come out to be a nice little pretty square. Okay, we'll say that this square has S, P, Q, and R. Okay, now what I will tell you, okay, is if you are feeling confused, do not be discouraged at all. Okay, geometry, as we go through stuff this whole year, okay, at the very beginning of stuff, you will feel lost. Stuff will start to make sense. Okay, it's just a lot of new stuff. It really is. Okay, it's different stuff from what you've done before, right, Gage? Yeah. Gage has been thinking so hard that he's about to pass out. Okay, so
hard.
now we're going to find the area of this quadrilateral. Okay, to find the area of the quadrilateral, you have a couple different ways that you can do this. Okay, now on a square, do we already know how to find the area?
Yeah.
Okay, what's the area of a square going to be?
Length gonna be length times width. Length times width.
So if I have it over here, we've got area is length times width. We already said the length was 5, and the width was 5, right? Because it's a square. So the area of this triangle should be 25, and we would say centimeters squared, or squared centimeters, okay? Now, you use partitioning when you have a shape that's just not as easy to use stuff that you've learned in the past, okay? So now we have all these triangles, okay? Can we find the area of a triangle?
Yeah.
Hopefully we can, okay? So if we were finding the area of a triangle, okay, so let's say I'm going to use this triangle right here. You don't need to put an X, but that's just the one we're going to use, okay? So A was the point 1, 4. D was the point 4, 0. Okay? Can you tell me what the length of QD is? What's the length of QD? D?
3.
Yeah, 3. How do we know? Because we're going from 1 in A to 4 on D. Okay? So the length of this part right here is 3. Okay? I would say one of the most important things about this class is that you label your pictures as you find information. Okay? So if we go from the length, okay, this long side right here, what is that length going to be? It does. I was going to say it does got to be 4. Yes, it is 4. Okay, because we're going from the 0 of D to the 4 of A. Yes. Okie dokie. They gotcha. Okay. So what is this length? We said 4.
Oh yeah.
Okay. Nice.
See what you were pointing
Nailed
Then
it.
By the way,
So what is the area of a triangle?
6. Well, it's base times height divided by 2.
yeah. What he said.
Okay.
You.
So it would be 6.
So it would be 4 times 3 over 2, which is going to give us 6. Okay. Now are all the triangles going to be that same length?
Possibly. No. I want to say yes because it's a square, but my senses are telling me no.
Okay. Interesting. So, so I'm confused now because your first thing you said.
Since it's a square, it should be.
Yeah, that's what I'm.
I'm
Yes.
so smart,
So
man.
because this is a square, all those triangles are going to be the same, right? So this one is 6. This one is 6. This one is 6. This one is 6. What do those add up to?
6 times 4 is 24.
24. Is that the correct answer?
Yes.
No, 24 plus 25. We need a remainder. Square is 1.
Well,
Yeah. We have that little
yeah.
square right in the middle, okay? Which is going to be 1
by
1 centimeter squared,
That's
right?
crazy.
That we'll just add to it. So
25.
you've got that 24 from all the triangles plus the 1 of the square in the middle, which gives us 25. And we already checked that that is correct, okay? So let's do what?
Well, what was that under that? The red area will be length times width.
We're just talking about what the area of a square is. Okay. Yep. So what we are going to get into next class, okay, is we're going to start classifying polygons. Okay. So we're going to start talking about, well, we're going to go all the way to the gon. Okay, but we're going to go triangle, which is how many sides? 3, all the way down to a decagon,
That's 10.
which is 10. Okay, and then
That's not an internal.
Yeah.
Huh?
Don't think
Oh,
Yeah.
that's a 3-dimensional.
it's like a sphere with faces. Yeah. We will also do a dodecagon, okay, which
Isn't that
is
20?
up to 12. It's 12. Yeah, a dodecagon. Okay. So we're gonna start classifying. Okay. This stuff right here, we won't really go back to doing a lot of area and perimeter stuff until we get into triangles specifically, and then we'll do regular polygons later in the year, and then we will do some more, I'll say, exotic polygons. Okay.
They can be confusing at times.